Welcome to a new video. Today we are going to talk about model evaluation techniques for regression models. Evaluating a regression model is different from other supervised learning evaluation metrics, and today we will uncover why that is and what metrics we should use. Before we start, let's set up our Python environment. We will be using libraries like NumPy, Pandas, scikit-learn and Matplotlib. So let's import them. We will import NumPy, Pandas. We will import train test split from sklearn. We will import linear regression from linear model. Import linear regression. We will import r-squared, mean absolute error and mean squared error from sklearn.matrix. Mean squared error, mean absolute error, and r-squared. And we will import Matplotlib at the end. Here it is. I imported various libraries that we will be using throughout this tutorial. NumPy and Pandas for data manipulation, scikit-learn for modeling and evaluation, and Matplotlib for visualizations. Now let's generate some sample data to work with. I will create a synthetic dataset of house prices based on FE features. Actually, let's keep it simpler and let's create only a single feature. Let's say x is equal to 2 times numpy.random. We will say 100, 1. For the y side, we will say 3 plus 4 multiplied by x, and numpy.rand 101. And then we are going to create a data frame with this data, pd data frame numpy. We will say x and y. Then we will say columns. Let's say living area and price here. Also, let's write this with capital letters and let's get this data frame. Here x represents the living area of a house and y represents the price. We also added some random noise to make it more realistic. Before building our model, let's split the data into a training set and test set. So I will say xtrain, xtest, ytrain and ytest. Then I will use train test split and I'm going to say df living area, and then I will say df price, and I'm going to set the test size as 0.2, which means 20% of the data is going to be in the test set. So we have the 80% of the data in the training set and the remaining 20% in the test set. Now let's train a simple linear regression model. So we will say model is going to be equal to the linear regression, and we are going to say model.fit xtrain ytrain. Here we initialize the linear regression class and fit the model using the training data. After training the model, let's make some predictions on the test set. We will use the predict method for this. Model.predict. We will say xtest here. And here it is. Also, let me show you the ypred here. You can see here is our prediction. The ypred array now holds the predicted house prices for the test set. Finally, let's talk about the evaluation metrics that we can use for regression models. Let's start by talking about mean absolute error. Mean absolute error represents the average of the absolute differences between the observed and predicted values. Observed values here means that the real values which was in the data and the predicted values are our predictions. So let's say mean absolute error here, we will say ytest and ypredictions, and we will say print. Let's use an f string here and say mean absolute error, and we will say like this. Here you can see our mean absolute error. This is one of the metrics we can use on evaluating the regression models. The state of this result is good or bad depends on the data, your target variable, your goals. So we can't say out of things, it's not stable. I'm just going to show you the metrics here and you can apply them into your cases. Now let's talk about mean squared error. Mean squared error takes the average of the squared differences between the predicted and actual values. This gives more weight to larger errors. Each evaluation metric has its own benefits and disadvantages, so you need to use the best one for your case. Let's say mean squared error here, y-test and y-pred, and let's print this like we will use f here, mean squared error, and we will say like this. Here it is. Now we are going to talk about r-squared. The r-squared score represents the proportion of the variance for the dependent variable that's explained by the independent variables in the model. So we will say r-squared score, y-test and y-pred, and let's print this like r squared and let's say r2 here. Okay, by the way, I just said I'm not going to talk about this score's goodness, but this is an amazing r-squared score and it's really hard to achieve this in real-world datasets. Now we are going to talk about root mean squared error. Root mean squared error is essentially the square root of mean squared error, which adjusts the scale of the error to the scale of the actual target values. So we will say root mean squared error, and we will say numpy.square root, and we will use mean squared error here, and we will say y-test and y-pred. And let's print this. Root mean squared error, and we will say root mean squared error here. Root mean squared error is sensitive to outliers, but it's one of the most widely used metrics because it adjusts for scale. Now we are going to talk about mean absolute percentage error. Mean absolute percentage error gives us the mean of the absolute percentage differences between the observed and predicted values. This is useful when you want to understand the error in terms of percentage. So we will say numpy.mean, we will say numpy. Then we will say y-test minus y-pred divided by y-test. Also we need an underscore on here, and we will multiply this by 100, and then we can say mean absolute percentage error, and we can say, and we can add this here. Now we are going to talk about explained variance score. This metric provides a measure of how well the model's predictions approximate the true values. A score of 1 indicates perfect prediction. So we will import from sklearn metrics, we will import explained variance score. I'm going to fix that real quick here. We need an R in here. Great. We will say explained variance score. We will use what we imported, and we will say y-test and y-pred. Print explained variance score, and let's just use it like this. I'm not going to capitalize. Here it is. So that was all for our regression metrics. Thanks for watching my video. I'm creating similar content. I'm creating videos on the topics of programming and data science. You can follow my channel for more. Have a great day.